to start the session. Moderator, please. Yusuf, you can start now. Yusuf.
All right. Good day, everyone. Welcome to the Elite Global Excellence Workshop on the AI-driven third millennium smart world. My name is Yusuf Mustafa, and I'm thrilled to be your moderator today, and we have an exciting agenda ahead. I would like to start by acknowledging our amazing engagement from countries all over the world during our 9th virtual workshop. So let's kick things off with a brief introduction to set the tone and give you a sense of what. Let's delve into the fascinating world of Elite Global Excellence. Established in April 2021, Elite Global Excellence is a leading research and innovation center fostering global connections. Our services encompass collaborations, conferences, project grants, trainings, and many more. Committed to supporting new ideas, we offer career opportunities, scholarships to contribute to the global research communities. Our mission is committed to fostering collaborations, innovation, and excellence in academics and professional realms. We catalyze growth by providing diverse services and opportunities for researchers, scholars, students, and professionals. Welcome to our virtual workshop series 2024-2025. Our virtual workshop series aims to address the global challenge of unequal access to education by providing free learning opportunities to students and scholars worldwide. Through this initiative, we at Elite Global Excellence seek to achieve those key objectives. The elimination of barriers to education, fostering learning and skills development, encouraging the exchange of knowledge and collaboration among individuals, and lastly, empowering and connecting communities through the pursuit of learning. We have successfully conducted 9 workshops, but we're still aiming high with 20 more to go. Without further ado, we are honored to welcome our speaker for today, Professor Dr. Eduard Babulak, a globally renowned scholar, researcher, and engineer with over 30 years of experience. He is a fellow of the Royal Society RSA, a chartered IT professional fellow, and a senior member of IEEE and ACM. Professor Eduard has spoken at leading institutions like Oxford, Cambridge, MIT, and Tokyo University. His expertise spanned AI, smart education, robotics, Nano-Bio Technologies, and semiconductors. With multiple doctoral degrees and editorial roles in top journals, he is a driving force in global research and innovation. Today, he will be presenting his keynote on the AI-driven third millennium smart world, exploring AI's role in shaping a smarter, more connected future. Please join me in welcoming Professor Dr. Eduard Babulak to the virtual stage, as he will now share his insight on today's topic. Feel free to jot down any questions that come to mind during the presentation for our Q&A session at the end. Professor, the stage is yours.
Yes, hello everybody, and thank you very much for your kind introduction. Can everybody hear me?
Yes, Prof.
And can you see me? Can you hear me?
Yes, Prof. We can hear you. We can see you, Prof.
Perfect, perfect. So once again, Dr. Mustafa, thank you for excellent work that you do and introduction of your workshops. I believe this is essential in today's world. I believe, in my view, we are at the very beginning of new era. And that era actually will bring new scholars from places that people don't often think about. Because I think what the world needs today is actually a new genius. And that genius, a boy, little girl, could be born in the middle of Asia, middle of Southeast Asia, Africa, Indonesia, Australasia, whatever. There's no borders. I'm very grateful for the invitation, and I actually had privilege working with colleagues in your region, and we actually did a lot of conferences, a lot of talks. Today's lecture, and actually my address is rather perhaps untypical. I thought I will not do a PowerPoint presentation because students and colleagues, you see thousands of PowerPoint presentations. The purpose of this talk is to basically incite some discussion and reflect on where we are and how technology will transform, and already did, is transforming human lives. So I believe in my audience, I have scholars, distinguished scholars, I have faculty members, students, and colleagues from administration. Am I correct? And of course, from many, many, many countries.
Yes, Prof.
Yes, Prof. Yes, Prof.
Excellent, excellent. So first of all, let me start with a little introduction. What I see and what we discuss often at NSF and in European Commission and other forums is basically trying to figure out how we can promote a interdisciplinary collaboration across the globe. And of course, from your end, I already see that you have, a lot of practical collaborative links established with colleagues all over the world. But there are still many institutions and many schools that may have somehow less privilege and even being deprived of access to all the resources that there are available for students and scholars at prestigious universities such as Oxford, Cambridge, MIT, etc. So actually the whole purpose of learning and the reason why we're here, because we are learners. And what's wonderful about learning is that learning should never stop, and it doesn't stop. There's an old Iranian, actually, proverb saying that rivers, water that flows is always fresh. And that kind of is similar to human mind. Human mind that continues to learn is always fresh. And to some extent, everybody who is willing to learn and study has that unbounded dimension of youth and excitement of discover and learning. There's another proverb says that if you want to refresh your mind, have a look at algebra or perhaps calculus and just start from chapter 1 and read calculus or any mathematical books. It's interesting that the human nature is made of that, what we call natural intelligence. And indeed, there are a lot of different tests and stating the IQs to a certain degree of many different people in many different fields. But yet again, we see that technology, with the rise of artificial intelligence, actually brought that capability of what we call computational complexity to gently starting assimilating human nature. Now, of course, a dimension of rise of AI from generative to a smart AI is philosophical. And indeed, something that technology have not mastered yet at the moment to embrace is human values. And of course, as we are now in the forum of meeting, from different parts of the world, from different cultures, different background, different philosophical background, ethnical background, we are all, in my view, I humbly believe that we are all like brothers and sisters because we are scholars. And the purpose of scholasticity is actually bringing enlightenment to every corner of this planet. So enlightenment means that we are all sharing knowledge, we learning, we discovering, we have inquisitive mind, and we wish to understand and comprehend all technology. But most of all, I remember during my Master of Science degree award in London in 1991 in UK. That was my second master degree then. I remember a distinguished professor who was then awarded Doctor of Science degree. He made a statement, and that was 1991. Then he said, technology had risen to such a level of intelligence that is now beginning to control and manipulate humans. And that was 1991. Now, if we can think about, then he added, he said, we all scholars, researchers, educators, scientists, engineers, decision makers, we have to work together and we have to establish what we call ethical professional boundaries where technology must never harm, never abuse humans, and it can only and must and should contribute to a betterment of mankind. So yet again, this is 2024, 25 is coming, and we are yet again at the new horizon, the beginning horizon of ultra-smart cyberspace. Of course, what we do now, right now, this is quite amazing because I used to work in your region in South Korea, Japan, and I've traveled across Pacific many, many times. And often a lot of colleagues and people who didn't visited your part of the world, I would say part Indonesia, Malaysia, and Philippines and Southeast Asia, a lot of people do not appreciate how big is the world beyond United States and Canada and Europe, etc. And so in that respect, I also believe that it is now the beginning of trying to connect and trying to develop that human mind, not just MIT, Oxford, and Caltech and other prestigious institutions, but also work with your institutions. And of course, your institution then work with local community colleges and schools and elementary schools, because the training of a what I call a super brain, master brain, begins at kindergarten. And what I saw, Dr. Mustafa, in your brief presentation, you had 4 points, which I believe that you have addressed all these essential pillars of education that will contribute to society, because you mentioned university, colleges, collaborating, and communities. And indeed, I can bring one example that was during my research studies at the University of Ottawa. We were working with Dean and basically looking for brilliant minds for young, well, for students, who would come to our faculty, and we offered quite generous scholarships. But the condition was, of course, that these are the best students from the best. And very often, some of these top students came up from countries much less privileged than North America or Europe. And so what's wonderful about all these students that now they are a well-established scientists and researchers and scholars. And of course, at the same time, a lot of them are working with people all around the globe. So I have mentioned the rise of ultra-smart cyberspace. What we do now is quite smart. We can bring together some 2, maybe up to 300 people. And I am in North America, and there may be colleagues from North America, United States, Mexico, Canada, and of course, Europe and your part of the world, which is quite amazing. This is a real time, and we can do that. So that is thanks to data communication. And I remember back in London, 1990, when we started to look at some very simple novel network and first kind of Unix operating system when we tried to basically exchange some text messages. So, of course, the Ethernet has evolved, and the brilliant idea of Ethernet was to create a channel of communication that would allow for sharing and eventually a basically treating data and develop some ideas. Now, if you look at the next stage that we went through was multimedia communication, and that was text, sound, and audio. And of course, these were technological challenges. During my studies, research studies in multimedia communication, in Ottawa, in Canada, Ontario, we had three major corporations. One was Nortel, the telecommunication, Mitel, which specializes on voice communication, and of course, Newbridge, which specializes on ATM switching technology, asynchronous transfer mode technologies. Now, of course, that was a time when I can give you an example where Nortel approached University of Ottawa and offered a significant grounds saying that we need 5,000 engineers being trained in the field of telecommunication. And that was somewhere, we're talking 1995, 1990. So again, 30 years ago. So what we'll see now with the rise of AI, the similar pattern of developments that is most urgent is now to groom, educate young scholars, students, children that would come back to fundamentals of mathematics, physics, and of course, computer science. Very often, perhaps some people may naively think that computer science does not require hardcore mathematical sciences. And in my humble opinion, and perhaps my own background, I remember 1976, it was 1976, one of my first jobs was to work as a telecommunication technician then. I didn't have a university degree, it was just a college degree. And I worked on the telephone exchange station, which was relay-based. And of course, from electronic relays to electronic tube, transistors, etc. So I had privilege to actually work on all across those fundamental, what we call telecommunication technologies. Now, with the rise of Ethernet, first priority was then quality of service, making sure that, for example, a session that we have now, that we have a good audio and video. And of course, behind this, there's so many protocols and so many procedures that require engineering, making sure that we go through all 7 layers of OSI model or TCP IP stack, and basically all this digital information starting from basically me facing my laptop here, actually, that you can see and hear my presentation in real time. So quality of service was essential and still is essential. And there are some perhaps studies or perhaps views that Ethernet is like a highway. And of course, you build, if we have colleagues from civil engineering, similar, you have all this transport infrastructure and there's so many cars. But the rise of cars on the highway, which is equivalent to data packets on Ethernet, have increased exponentially and is rising and rising. So there's a hypothetical question: could we come to that moment when there'll be one application that will crash Ethernet? What would it mean? We can't even imagine today living without Ethernet. Perhaps on occasion you can get a power shortage, and of course that could be due to different phenomena, natural phenomena, malfunction of etc., etc. And it's indeed a quite unusual experience. Like it or not, we have all, yet me having first computer somewhere at beyond the university. I remember it was quite some time after my graduation that we had first laptop available. So we have all become a cybernomans. We are assimilating technology. Technology has become essential to us. And I can imagine if I would ask your colleagues or our audience, Dr. Mustafa, please ask them if they would agree to leave their cell phones and that you collect all the cell phones and eventually destroy them? Please ask them if they would accept that. What's the reaction in the audience? I can imagine. Dr. Mustafa, can you hear me? It's
Yes, I can hear you.
quite traumatic. Yeah, quite traumatic.
Of course
My
it would.
God, I should give up my cell phone. Yeah. Nobody gives their private cell phone to nobody, because having a cell phone in their pocket, it's something like you feel that you are complete. And if you think technically, of course, from the engineering standpoint, all it is just a electronic device. It's just electro kind of mechanical device that uses that Ethernet, that uses that communication technology to visualize, to access data, to process data. So we are, and we have become, a cyber dependent. And that cyber dependency is, of course, a wonderful thing. Ethernet is wonderful for learning, for exploring, for getting up-to-date news, etc., etc. And now, of course, with so many millions and millions of books available, so there is no need necessarily to have all these hard copies of books and journals and etc. Many of us are learning online and reading online material. So this is 2024, and we have discussion on AI that actually already with Elon Musk and other colleagues all across the globe starting to speculating, is the AI, to what extent should AI become omnipresent and ubiquitous and pervasive in its nature? And does AI, or will AI, or should AI contribute to the betterment of mankind? Answers, of course, are very complex. And indeed, we see that, yes, it is a wonderful technology. But of course, colleagues who work in the AI industry, actually, it's quite known that AI is also very expensive, because it's expensive on the computational cost, on energy cost. And so, yet again, there are other challenges that AI, similar to quantum computing, didn't get to that level yet, where, of course, we have small AI, if you like, application to certain extent now on the smartphones, and we see that with Samsung and other, Apple and other technologies, smart technologies. But still, will we ever come to that point when suddenly, like what Apple smartphone today is, often considered as a supercomputer that, if you look some years back, and I remember perhaps, talking with Professor Gottlieb, who was one of the makers of ENIAC computer. And if you don't know who Professor Gottlieb was, he was a founder of the computer science department of the University of Toronto in 1945. So it was one of the most distinguished scholars in Canada. They called him a father of computing in Canada. And so he humbly said, then, I remember I met him in Quebec in 2004, and 20 years ago, and he was concerned with the fact that the computerization of technology had advanced so much that is now really taking control of financial systems, of ecosystems, of defense, of security, etc., etc. So, of course, we all have to kind of, yet again, as engineers and scholars and scientists in the field of engineering and science, we are all passionate and we want to push the edge of technology. We're looking at, rise of humanoid robotics, where, of course, robotics or humanoid robots are beginning to look like us. They're beginning to have a tissue, human-like tissue, that eventually what might happen, that you may be sitting somewhere in the coffee shop and have a humanoid robot sitting in front of you, and you won't even notice that this is a machine. So, of course, may sound a little bit of science fiction, but there are already experiments and there are already if you like, humanoid robot. Surely everybody knows of Sophia, a smart robot. And what's interesting about Sophia, that to one extent, during one of her interviews, they asked, would ever robot be in position of attacking humans or confronting humans? And Sophia replied, well, we have not yet. One of my most recent projects on humanoid robotics and future education, which you may find, if Dr. Mustafa, what I will ask, if you would share a couple of links I send you with audience and they can look at my work, and eventually we can have a follow-up production because it will be too long to talk about everything. But some of these projects are a couple of books I'm working on now, and one of these books is, of course, on humanoid robotics in support of education, where similar to medical care. I remember in South Pacific, we worked with Yokohama University on medical application via satellites, because, a lot of these small islands in South Pacific have basically, they need an expert, a medical expert. And of course, to have a consultation through like similar what we have now, so communication in South Pacific is more viable via satellite because cables and everything is quite expensive. And so similar in education, I believe that we'll come to that point where, for example, Dr. Mustafa or other colleagues, you have a lecture and you say, well, I'd love to have maybe on that particular lecture, Professor Babulak in my class. And so we can agree on time and I can come to your class and we can kind of do this virtual collaboration. One example, of course, and of course, in-person collaboration. There's also discussion, will ever distance learning be equivalent to in-class experience? And answers are yes or no. Of course, there are a lot of reasons, because I think that human interaction is still essential, but as a complement, I think it's important to use all these available technologies. And so for that reason, I also believe that it is essential that research, innovation, and development, and what you already, I believe, started to work, that there are centers of excellence for research and innovation, development of next generation of ultra smart technologies everywhere on the planet. And again, places that might be much less privileged than others, because the genius, and I'm saying again, genius, little boy and little girl, if they get proper training, they may rise the level of science and discovery to much higher that we can't even imagine. So with that note, I just want to say I'm optimistic about the future AI. I believe that together as experts, we should be able to also make sure that we control technology, so we establish ethical and professional boundaries, so that technology will never abuse, never control, never manipulate, never put in harm human people. And at the same time, also, that every child on the planet, everybody on the planet, have access to best quality of education and best learning experience. So with that regards, I'm going to invite questions, discussions. And of course, I do appreciate that the scope of or imagination of ultra smart cyberspace, people would often think, oh, this is something that is available for example, at Seoul National University or MIT or John Tong University in Shanghai or University of Beijing or University of Oxford or Cambridge. No, I humbly believe that now that we all have smartphones, access to smart technologies on the market, that supercomputing centers are all across the globe. So let's have a discussion. And perhaps what I would do first, I will invite questions and we can develop from that question to perhaps So thank you very much, Dr. Mustafa. Thank you, dear colleagues, dear audience. I hope you have enjoyed my brief introduction to my views. And of course, if there's anything that we won't be able to cover because of the time shortage, we can agree on perhaps follow-up session, or we can somehow find a way of collaborate. I would also be honored to come to visit and also make sure that we are working together so we can push the level of excellence. And who knows, the new MIT might be just somewhere beginning right where you are. And all you need to get to that level is to start learning and be open-minded. Thank you very much, and I look forward to questions.
Thank you so much, Professor Babulak. Your insights on this topic have been really great. And now I want to open the floor to all of you. Your thoughts, queries, reflections are an integral part of this workshop. So let's make this interactive. Drop your questions in the chat and I'll fire them off to our speaker. I think we have our first question here from Nida. What industries or sectors should we focus on to align with the AI-driven smart world?
Well, of course, number one is internet, computing, robotics, transportation, and of course, education and health. These are, I believe, given COVID experience, what we saw. And of course, next to natural disasters, there must be also technologies that will protect and control energy supply. Because I think energy, and most of all, I would add food supply, agriculture. So what you should focus on, I go perhaps in reverse order, in my view, is food production, healthy food, healthy agriculture, clean water, clean air, of course, the energy, make sure that, there's no power shortage. And we saw what Vanuatu just happened, the earthquake in Vanuatu and places close to the region. So infrastructures, make sure that you have a cyber critical infrastructures in place that are able to withstand any earthquake, any tsunami, any cyclones and disasters. But at the same time, also working with the government, local governments on smart transportation, on smart education. And of course, when I started with the smart word, so the smart word is basically the use of word smart means efficient, technology that actually works for people, technology that actually, if you look at financial institutions, banking, you also have to develop some contingency planning where the infrastructure that you have could be destroyed because of natural phenomena, or hopefully never because of war. But indeed, contingency planning is essential. It's to always have a plan B. And also delegation. Delegation means that you have technologies that actually are complementing each other. So that's a brief answer.
Thank you, Prof. I hope this answered your question, Nida. We have another question from Muhammad. Where should a civil engineer begin with learning from in the scope of this topic today?
Where the civil engineer, could you repeat the question, please?
Where should a civil engineer begin with learning from? I believe it means in the scope of today's topic.
Smart buildings. One of the projects that we work on back in Virginia was a smart building that is self-sustained, that actually has all this water, from rain is recycled, transformed, converted to energy. So number one, again, that was a smart building in regards of facilities, regards of utilities. And of course, if you have, and again, what we see with the cyclones, when the buildings are destroyed, so to look at new materials. So the civil engineer, first of all, where he should start, or anybody who would like to become an expert in civil engineering, should learn mathematics, physics, chemistry, and of course understand materials, understand the energy, thermodynamics. So I think it's a heavy, computer from the statistics and statics point of view. So it requires a lot of fundamental studies in mathematics, physics, and chemistry and materials. At the same time, a civil engineer, in my view, should be an architect, should be someone who understands the interior and exterior design, someone who is able to work with AutoCAD and, of course, all these CADs and all these, computerized design systems. And at the same time, there's also next generation of civil engineering, which I call a smart building engineering, where the smart buildings will be like hubs of computational and energy supply for other buildings.
Thank you so much, Prof. I hope this answered your question, Mohammed. We have another question from Nida. What skills or tools are critical for becoming an AI leader in the third millennium?
Well, I think, first of all, in the AI, what we see today, they're not necessarily only computer scientists or electrical engineers. The AI, in the field of AI, or if you like, in the community of AI leaders, we see businessmen, we see a lot of decision makers. So I think, first of all, anybody who wants to get involved in AI should start with learning fundamentals, what AI is. And of course, that means fundamental of computing, little bit of maybe programming, little bit of algorithm development, and appreciation that actually AI is computing. It's fundamentally just more complex computational capability. Of course, at the same time, AI has a lot of different fields of application. So people coming to AI could be a little local store that may develop system of perhaps predictive analysis and being able to predict what goods he or she should provision the small shop. Or AI should be a university faculty member expert who understands the enrollment, who understands the student progress and in the advancements in the studies, who also understands the ideas of financing and grants and making sure that university has enough funds to develop and to continue. And at the same time that there are students who can, after graduation or before graduation, they already can start their little bit own, if you like, business supported by university. So the AI is an open umbrella. There is no discrimination saying, oh, you cannot be AI expert because you don't have a PhD in computing. I disagree. You can. But of course, you have to, first of all, or anybody who likes to get on board has to be competent in their own field of studies and to have a solid degree and solid fundamental knowledge of what AI is, and also be trained to become visionary, trained to become able to put together, to connect different disciplines, different needs of society, and say, well, if you would have a waste management, and if you would have an intelligent waste management, perhaps, or if you would have a fish, or ocean kind of environment management, or forest or land management, etc., etc. So it's all about a resource that is available for survival. And so I think anybody can come on board, but everybody who is willing to come on board must be open to learn and to be humble enough to admit that there's so much more to learn.
Thank you, Prof. We have another question from Paul. Paul is saying, I understand all the theories, mathematics, and statistics around reinforcement learning. My question is, how can I go about the practical implementation of the learning?
Well, you can develop perhaps problem solving, and you can pick up any economics or accounting or calculus or whatever, problem from any major course, and look at how you learn. And you see what happens in the classroom very often, that professor, faculty member, and of course we all went through this, when you're preparing your lecture, you actually preparing, you are learning, we are all learning the particular chapter to make sure when we work in a classroom that we have clarity and simplification. But for students, for the people who are learners, this is all new material. And so we have to find a way how to simplify, how to clarify. And so that way of simplification and making sure that that particular subject becomes accessible to anybody in your classroom. So that is a mastery of teaching. And yet again, for that reason, you can now utilize and a lot of visual tools, and of course, a lot of mathematical tools. And some of the software, unfortunately, is still very expensive, like Maple, Wolfram Mathematica, MathCAD, in mathematics, for example. But there are similar in tools in accounting, which are computerized tools. And of course, as far as learning, we have now different blackboards and canvas and so many different technologies. So I think it is not naively to take technology as if technology will solve the problem automatically. No. Technology is only an assisting tool, but fundamental tool or fundamental resource is a master, is a teacher. And so that teacher has to develop a technology that will actually be to some extent automated, but yet making sure that everybody in the classroom can comprehend. And then when at the end of the lecture, when you have students coming to outside the classroom and saying, wow, I got it. So that means that our job was done. But if students coming out from classroom and they're completely puzzled and completely confused, it served nothing. So it's a mastery of delivering and simplifying the subject. And to that mastery, technology could be a great help.
Thank you, Prof. We have another question. Okay, so what harms this AI technology can provide to the next generation?
Excellent question. And I'm almost sorry that we have to even talk about this. Yet as we all are so passionate, we all look forward to the new edition of cell phone, like Windows. Remember from 3.1 to Windows 2000 and Windows whatever now. So thousands of versions and updates. And so similar Apple 14, 16, 17, eventually we have an Apple cell phone 2075. Yeah, it will never stop. But one of the examples where technology is on the crossroads with the practical use are children. Because if you have small children, and we all were small children and we remember our childhood. So in my case, I was, in the garden, hanging on the trees, always in the dirt, always with the animals, always playing in the ground. So I think I had a wonderful childhood. But what you see today, a lot of young children, they sit in the corner with a small tablet or cell phone, and they are in the virtual cyberspace, and they are disconnected. So there is a huge danger from the psychological or sociological point of view that technology must be controlled. And of course, it's about parenting. You can buy a smart device to your child, but you must say, okay, you can play with this half an hour, and then another 2 hours you go outside and you play soccer with your boyfriends or girlfriends or with your friends. But so there must be that balance of not become victimized by technology. And this is just a very simple example. Another example, of course, in the world of finance is when the intelligent AI-driven technology may take care of or overpower the stock exchange. Or, as we all know, it's all about in the system of finance and banking, this is one of the most crucial. Other aspect is, of course, weaponization of technology, applications in military in many different ways. So again, what's most important is as technology is developing, we must always be able, and of course, the experts who work on these technologies should have certain ethical and professional conduct, like similar to ACM, IEEE Code of Conduct, where we say, okay, we move on with technology. So same with the smart cars. And we see that with Uber, that some of the tragic events already occurred. So technology is never perfect, and it will always be challenged. So that level of perfection is something that we may always measure and assess, but unfortunately, it's almost impossible to get any technology. Like us people, we are not perfect. Nobody's perfect. But what we can do, we can learn how to respect each other, how to learn from each other, how to honor each other's views. And so we do that as humans. But machines also will have to learn and must learn how to learn from us. So that, for example, if there is an old lady crossing a street, or old person or small or mom with a baby, that the car, automated car, will automatically make sure that it will stop. It will not, even if it's a green light or red light, will work for pedestrians. So, of course, you have to take scenarios, and based on all these scenarios, you have to study them. You have to make sure that there are certain flags, certain alarm flags that will say, okay, at this point, technology becomes secondary. First is human life, human safety.
Thank you, Prof. We have another question. Could you share examples of successful AI-driven smart projects that we can learn from?
Well, there are many. Amazon, Google, Microsoft, Apple, Samsung. I think, perhaps take Intel and Samsung or AMD, the microprocessor developing technologies. So in computer architecture, what we see now, that we went through the multi-core to multi-threads and now super computing architectures that are actually available on the laptop level. So I think this is one of the examples where, this AI-driven a laptop, take one just example, or smartphone, cell phone, like Apple and Samsung, and we see now, of course, the Google phone. So this is the beginning. Yet again, all these technologies, you would have to kind of look at, say, okay, if you have a smart TV, and I'll come back to examples of smart TV. So it's so fascinating, because smart TV is basically like Android TV, one of the examples, when you can watch YouTube and you can watch everything. And eventually, what people haven't noticed, or some people naively kind of disregard, is the fact that you have a camera and you have an audio on the smart TV. So if you put that smart TV in your bedroom and you watch the world through the internet, there are ways that internet can actually watch you in your bedroom. If you have a smart house and you connect everything, control of your house, your garage, your garden, your car, even your children's surveillance, if you like, to some extent, if you can control it, anybody else then can control it. And of course, so that is yet again another dimension, and that is cybersecurity. And so I think it is essential and still most challenging to connect the development of ultra smart AI-driven technologies and at the same time to develop a cybersecurity mechanisms. Because if a high school student can break into a local bank or local school or whatever institution, imagine what the AI-driven supercomputer can do. So I think this is, again, putting in perspective any smart device that we have access, cell phone, laptops, wonderful, smart TV. But at the same time, there must be also appreciation of the capabilities. If you have a smartphone in your bedroom and you watch the internet, surely internet can watch you back, and basically you have the whole of a lot of people in your bedroom and you don't even know it. So I think this is very important. It's to not being naive. When I give you an example, when the average person goes to a electronic shop and you say, "Oh, I like to buy a latest computer," so I think they should spend a little bit of time talking to salesmen or maybe even consult some experts and say, "Okay, I bought this cell phone or I bought this laptop. Could you tell me a bit more about its capabilities and maybe even some risk? What are the potential risk or potential whatever beyond control things?" So I think, again, this question also kind of connects my previous discussion on children. And of course, eventually making sure that anybody, when you have a account somewhere or you have a health record somewhere, that your medical record is safe, private. And so all this data, because remember, any digital data that we have developed and we have shared is stored on data centers. This is true internet, and it will be there for the next 10,000 years.
Thank you, Prof. We have another question. What do you think about startups in the AI-based industries? How can we get ideas and build great startups through it, and how to get started?
Well, first of all, let's say you have, and again, that comes to two different or three different areas. Hello, are we connected? So number one, as a faculty member, you have computer science class and you have, say, brilliant students in your classroom. So I think the very, very beginning would be projects. And, projects maybe in the computer science class, or software development class, or some advanced courses, senior courses, and you would have a project when you would maybe gently try to inspire students to go beyond the undergraduate level and start a little bit of digging and researching and maybe developing something that could be, like, to some extent, intelligent application. And of course, through the project presentation, I would also go into classroom like accounting and say if they can develop computerized accounting system that can use AI. And you can go to any classroom on biology, on chemistry, on physics, on any mathematics, and any field of study. So I think it is to basically look at, and of course we all know in that academic environment, computer science often stay apart from people like accounting department or engineering department or mechanical engineering department. And of course, I think that open roundtable discussions and exchange of ideas and bringing people together and say, you know what, I went for a walk and I see that old bridge, rail bridge, and I noticed there's a lot of corrosion. So eventually that bridge may collapse and the train may kill many people. So it is from simple observation of surroundings, of infrastructure, such as transport or buildings or anything, and then say, okay, could we develop or do something about it? And so that do something about it is not technology, it's us people. We have to have an idea, observation, and then go back to classroom, invite your colleagues, maybe create a consortium of experts at your school, university level, and start develop a applied research, and research that can go to a seniors or graduate students, and they can then eventually develop their own startups. Another example is local business and industries, where you need to kind of make sure that you are well connected to business, because every project requires some sponsorship, money. And if you talk to business people, they will always ask, and what's in it for me? So there must be some cost analysis and some eventually benefits, mutual benefits, and same for industry. And so in that respect, I think you don't have to be in Boston, or you don't have to be in London, or Los Angeles or New York or anywhere. It could be just right where you are. But with the businesses and community, as you mentioned, community means, of course, business, government, industry. You need to start talking, exchanging ideas, and maybe learning, say, okay, look what they developed in Vancouver, they smart transportation. So could we do something, on much smaller scale, or, smart health, smart, so anything that is smart could be done in small scale. And eventually through innovation, you increment and say, let's start with the lab. Let's maybe go from lab, maybe go all across the department. Maybe we do a interdisciplinary cross lab. And then we go to application when actually people from outside the academia can see, wow, these academics are not just theoretical people, but they are really practical, and they help our community to be safe, to have much better quality of life.
Thank you, Prof. We have more questions here. What are your thoughts on the potential of artificial general intelligence, AGI, surpassing human intelligence and operating beyond our control?
Well, of course, there are so many science fiction movies now, and they are not, unfortunately, they're not too much science fiction anymore. So this is it. We are, and I would say, in my humble opinion, remember transistor in 1945? So maybe, of course, some of you won't remember, neither am I, but I'm aware I had learned about that era. And I've mentioned, my first job in 1976, the electronic relays, electromagnetic relays, for the telephone exchange station and rotary switches, from 0 to 9. So I think I look at the GI as a beginning of new chapter. And so in other words, we can say, okay, now we have a black and white TV, and now we're getting color TV. So from the technology point of view, this is yet just another increment. I don't see any drama. It's just part of evolution, technological evolution, and it's wonderful, and we have to be excited about advancement. But the question is, it is actually in application of technology, to what extent will developers or business-driven communities sponsoring those AI evolution to eventually reach the level of human intelligence? Some people speculate philosophically it will always be incomplete, because there's something about human nature, and of course that human nature has a physical body, if you like, a spiritual pillar, and emotional pillar. Now, physically, yes, humanoid supercomputers and robots may look like people, but the question is, would they be able to have that emotional pillar, like we are emotional people, and also would they have that spiritual dimension? So if you take these three pillars, spiritual, emotional, and physical, so yes, machines are able and will be able to assimilate physical of humans, almost that without recognition, that you may sit in front of a robot in a cafe and you think this is a human being. Now, also intellectually, machines may reach to some level, and they are already very smart. But I did mention that because of that ultra smart and powerful computational capabilities, these machines are able to learn much faster than us. So as I mentioned, to get to professor level, you have to have all degrees, and then you have to be assistant, associate, and then professor. You have to publish and prove yourself and lecture and do a lot of community work and other stuff. So it took a lot of years to become a professor. Now, could machine become from that very initial robot to level of professor machine, yes, maybe in much shorter time than us people. So in that respect, there are feasible possibilities, but again, we have to make sure that technology is always controlled by people. And the control of technology, of course, must be at all levels. This must be a simple person, old, maybe grandmother, maybe grandfather, maybe somebody who is just saying, "Oh, my son helped me, bought me a nice telephone." And it has to be always in helping tool. Now, when we go to a councillors, city councillors, mayors, and the government officials, then, where the big technology and big money are discussed, they also have to make sure, okay, we are now implementing a new smart transportation in the city, or smart health, or smart banking, or smart government, whatever e-services. But we also want to make sure that we have experts, qualified people, and if we don't have them, we invite them from all around the world, and we establish some metrics, assessment metrics, concerned to safety and, of course, basic rules. So I think it has to kind of grow together. You cannot naively just develop technology and forget the fundamental rules of ethics and professionalism. It has to be like, as I mentioned, humans, we grow in three pillars. We grow physically, emotionally, and spiritually. And so this machine will also grow, but will ever machine reach the human intelligence? Honestly, I often give an example in the classroom and at all levels, postdoc, PhDs, bachelor, and I say, what is the most powerful supercomputer on the planet? So I want to ask anybody in audience, can anybody tell me what is the most super powerful computer on the planet today? Dr. Mustafa, see if anybody can give us some suggestions. I'm waiting.
Okay,
I see
so
quantum
we have
computers,
quantum.
Alexa. I see quantum computers, Alexa, Google quantum computer, quantum. Okay. Anybody else? Anybody? Okay, so thank you very much. Well, excellent. I just got it. Our brain. So who is that? Ricardo. Ricardo. Well done, Ricardo. It is a human brain. And Hassan, same. Indeed, it is a human brain. In the classroom, I walk and I touch students' skull and I say, well, you see, right there, there's this most powerful computer. But the problem with this most powerful human brain supercomputer is that the key to start that supercomputer, students or anybody may have a key somewhere in the pocket, but they forget where is the key. So I think most difficult is to find the key and to unlock that supercomputer. Would you agree, everybody? Thank you. I agree. So, it's like if you are a parent and you have a, say, 16, 17, or 20 or whatever, a small child or young teenager or young adult, and they say, Mom and Dad, how could I possibly become successful? Could I possibly do my own big thing? And you look at them and you say, well, you know what? All you need to do is to turn your supercomputer on. And that comes with the self-confidence, self-motivation, inspiration, and guidance and mentoring and teaching. And then if we can do that, then you'll see in coming years, 10, 15, 20 years, that people will be not necessarily considering MIT being number one. It's going to be very hard to compete anyway. But who knows? Maybe the next MIT is right now, right where you are. This may be the first day of your local MIT. But it's to make sure that you are open-minded, willing to learn, and passionate to discover and master the subject.
Thank you, Prof. Okay, so we have another question. What would you want in a person who has started his journey in AI and wants to jump into the industry?
Well, if they go to AI as an expert, as somebody who have got the degree, education, training, whatever, then of course it's their own choice. They will have to basically pick up a particular company. I'll mention many, Google, Apple, whatever, local, wherever you are, and just apply and present their skills. So this is one way. The other way, if they are already developing their own applications, so to make some demonstrations, make some convincing arguments, and say, well, look at it. I was or we were capable of developing this. And so it's a proven concept of success. So dimensions many, subject where you can.
See, thank you, Prof. Would you be able to take more questions?
Let's do, you know what, if I may suggest, can we do 5 minutes little pause?
Yes,
I-
Prof. Yes.
Yes, I think we can.
Okay, let's have a 5 minutes pause. You collect the questions. And again, if we won't manage to answer all the questions, then we'll, we can continue and find the other way how to continue that dialogue. Is that okay?
Yes, Prof. Maybe you could
Okay,
share
so-
your LinkedIn or any way of communication where the attendees could ask you the questions directly.
So let's start with you. You'll be my communication point, but come back in 5 minutes, okay?
All right, no problem. Thank
Okay,
you.
5 minutes.